Good afternoon, everybody. Welcome to the technical session, Artificial Intelligence and Game Software Engineering and Programming. In this session, we will have five very interesting papers. And I will ask for everybody to put the questions, both can be on Wova, on YouTube. Since we have a delay in the according with the YouTube and the streaming system, we prefer if you put the questions during the presentation. So at the end of the presentation, we already have them available. So let's start the session with the first work, called Similarities and Divergence in Electronic Game Review Texts.
Hello everyone, my name is Vinicius de Souza Gonçalves and I will present the work called Similarities and Divergences in Electronic Game Review Texts. Like a film, an electronic game can be criticized concerning its elements, like gameplay, story, audios, visuals, multiplayers. Every year there is an event called TGA to reward the best game of the year. In addition, there is websites who post game reviews like IGN, Voxel, and Metacritic. Our objective was to answer 4 research questions. Research question 1. Are there diversion or similarity in the reviews between critics and ordinary users for each game by considering gameplay, audios, visuals, multiplayer, and story? Research question 2. What characters of the electronic game the ordinary users rate? Research question 3. What characters of electronic games the critics rate? Research question 4. Consider the games nominated to compete for the Best Game of the Year award at TGA. Does one have the best results for gameplay, audio, visual, multiplayer, and story features? With this, our goal was to verify the similarities and diversions in the reviews of electronic games between critics and ordinary users. Our method: we capture reviews from the Metacritic website using a web crawler developed in Python. We capture reviews from SBGames, Red Dead Redemption 2, Go, Uncharted 4, Overwatch, Race 2, Anthem, Left Alive, and Jump Force. We exclude reviews that were not in English and that had no score. And we use morphological analysis to identify adjectives and nouns. Nouns was adjective. To answer research question 2 and research question 3, we consider the frequency of an element in all reviews, either by critics and by ordinary users, for all games. To answer research question 1 and research question 4, we use 2 approaches. Analysis of the feelings of the adjective and noun relationship, an example is great story, and the frequency with the elements appear in positive, mixed, and negative reviews. On the Metacritic website, they use positive, mixed, and negative to classify a review using the score. And we balance reviews from different users, like ordinary users versus critics. So we analyze groups with the same size to compare. Some results that we obtain. In our results, we realize the element story is the most important for both type users among the session elements observed. Ordinary users consider the visual graphical elements necessary, unlike critics. Critics consider gameplay important to analyze games. Audio and multiplayer elements were not among the 50 most adjectives, most adjective nouns. So we exclude these two elements. In the analysis of feelings, we notice the frequency decrease concerning a category. So there's sometimes the user adject a noun in a positive review, but with the analysis, the feeling expressed, we realized that was negative or neutral. Go Red Dead Redemption 2 and Uncharted 4 games had a higher frequency of adjectives referring to the game story. Red Dead Redemption 2 and Uncharted 4 won the best narrative at TGA. Uncharted 4 Go and Red Dead Redemption 2 have a pretty high average rating from users for the visual elements. Overwatch game had lower average than the elements that we analyzed, mainly by critics. Go versus Red Dead Redemption 2. Regarding critics, Red Dead Redemption 2 and Go had story with the same quality level. The difference was minimal. Ordinary users show more often positive feelings about Go gaming than Red Dead Redemption 2. Critics express few feelings about the gameplay and visual elements of the Red Dead Redemption 2 game. On the part of users, Go gameplay is better than Red Dead Redemption 2, and ordinary users positively rate both game visual elements. Uncharted 4 versus Overwatch. The low frequency of observed feelings did not allow our analysis in the disputes between Overwatch and Uncharted 4 on the critics' part. It was impossible. To ordinary users considering graphic and story elements, Uncharted wins Overwatch. Regarding the Overwatch has no story. The gameplay of both games had balanced feelings. Finally, Anthem and Jump Force games present a shallow frequency of feelings. It was impossible to perform analysis with these games. Regarding Raging 2, there is a balance between feelings expressed to the elements of this game. And Left Alive was surprised because in Metacritic website, the critics negatively rated this game, but the users positively rated this game. And with our analysis, we realized that story is positively rated by users, ordinary users. So this is our work. Thank you, everyone.
Hey, thank you to the authors. Is the author present here? Yes, but we cannot hear you. Can you turn your audio? Let me see if we have some questions for them here in Wuva. I'm sorry. No, it seems that we don't have questions. I have a small question here. Do you use only the syntax of the word, or you use the semantic of the words? I mean, for instance, I can say, I am not very happy with this game, but I can understand that the word happy could be, if I'm only using a syntax manner, I could think, I mean, the feeling of being happy, but I'm not actually happy. So in some cases, I understand that we must go in a semantic way. And how deep is this semantic analysis made? Because in some cases, I think we will need some more robust artificial intelligence methods for that. I am not sure if it seems that the author didn't manage to enter in the system. So if he managed to arrive before the end of the session, we may ask him again. Okay, so let's go to the second work, which is evolutionary procedural content, which is the evolutionary procedural content generation for endless platform game. Please.
I'm here.
Oh, Vinicius, you're there.
I'm
Okay.
here. Yeah.
All right. It seems that you.
I see
Yeah.
you made a question. Can you?
Okay. Yeah. You make analysis of the words during the review. Okay. But my
Yeah.
doubt is if you use only the syntax meaning of the words or you go deeper in a more semantic analysis. For instance, I can say, oh, I didn't feel very happy with this game, but if I only look for the words, it may lead me to a positive analysis that I'm happy, but actually I'm saying that I am not happy. So how deep you go with the semantic analysis?
Okay. We use the two analysis. We use one to see if the review was negative, positive, or mixed, neutral, using the Metacritic website. So if you have a game and we have a adjective none, we get if that review was positive, mixed, and neutral. But we make another analysis to see if the sentiment analysis in the relationship in adjective and no, adjective and no relationship. An example, great story. So we see if that sentiment was positive, neutral, or negative. We make these two analyses using a morphological analysis between adjective and noun. It was this that we make.
Okay. Okay, thank you, Vinicius. Thank you very much. Let's go
Okay.
to the next presentation since we are running out of time. So please.
Greetings, everyone. My name is Rafael, and I'll present to you an overview of our work entitled Evolutionary Procedural Content Generation for an Endless Platform Game. According to Julian Tegelius, procedural content generation is the algorithm creation of content with limited or indirect user input. The content could be of any type, such as textures, sounds, environments, characters of a game, stories, poems, and so on. There are many approaches for this task, such as, but not limited to, random number generators, noise generators, evolutionary algorithms, and neural networks. This technique has been used in many commercial games over the past decades. Some recent examples of those are Minecraft, No Man's Sky, Spelunky, and Alto's Adventure. In this work particularly, the content we generate is the 2D block-based environment of a platform game. The maps are expected to be playable according to the game rules, potentially infinite, and generated in real time as the player explores the game world. This is a simple result for the approach in this work. To reach the goal, a genetic algorithm was implemented and experimented with. This approach is based on the theory of species evolution and searches for the best candidate solution for a given problem based on a fitness function. Here, each candidate solution, just like a biological individual, is represented by its genetic code that dictates its characteristics. The idea is that a group of individuals should evolve over the course of generations, such that after n generations, it is expected that the best individual is a candidate solution that meets the initial requirements. Here, each individual represents a finite chunk of the infinite map. Because we wanted each individual to be more easily dynamically appended to the game world in the x direction, we implemented it as a doubly linked list. Each node of this list is a gene column that has information for placing all the blocks in the y direction for its respective x position. Therefore, when new chunks are created, they may be easily appended either to the left or the rightmost corners of the game world dynamically. To evaluate how good an individual is, a fitness function outputs a numerical score that takes into account the density of enemies and power-ups present in the chunk, such that they lie between a reasonable range of values. It also accounts the width of holes in a series of jump simulations from any given safe block, such that it should be possible for the player to reach any safe block from any other given safe block by performing a jump. For every pair of parents chosen to undergo the crossover operation, we search for a compatible crossover point in a central region of the chunks represented by the parent's genetic code. By compatible, we mean that the ground height difference of both parents at the chosen point should not be higher than the player could possibly overcome by jumping. Then, the generated offspring inherits its left chunk side from one parent and its right side from the other. When a new chunk has to be generated, an initial population is initialized with information of its static neighbor chunk and a new complete randomly generated chunk. This ensures that the fitness function returns a score that indicates how well this new generated chunk fits together with the neighboring area it will potentially be appended to. Then, for each new generation, the best individuals from the previous generation are selected based on analytism rate. Then, pairs of parents are chosen with probability proportional to their fitness values, and crossover operations that were mentioned before generate the offspring. Then, the elite and the offspring are unified to form a new population. Eventually, this new population may undergo mutation operations with a low probability, which is the mutation rate. This iteration happens for a number of generations, such that after max gen generations, the best individuals satisfy the requirements encoded in the fitness function. We performed a number of tests, changing some of the parameters, such as population size, mutation rate, and analytism rate. The graphs you see here show the evolution of the fitness of the individuals for the first 1,000 generations. Here, these four graphs correspond to simulations of populations of size 10. Notice that a lower mutation rate of 0.5% is more stable and tends to converge to higher fitness values, whereas mutation rates of 2.5% or more are very unstable, especially for low population sizes. When we increase the population size to 50, like here, and 75 here, the conversion to higher values is smoother and the processing times are still acceptable. However, when we increase the population size too much, say for 250, the processing time also increases significantly. So one should increase it with caution and experiment what works best for the game rules and the hardware requirements. Some points that could be further improved is changing the stop criterion from a fixed number of generations to dynamically stopping the evolution when the fitness increase rate is not significant anymore. Furthermore, this approach could be expanded to 3D if the doubly linked list is replaced with a slightly more complex data structure. Thank you very much for your attention, and if there are any further questions, we look forward to answering them in the Q&A session.
Okay, thank you, Rafael. Very interesting work. Let me see first if we have some questions here. Otherwise, I have a question. My question is, well, you showed a platform game. I mean, that graphic is a platform game.
Yes, it is.
Okay, and how constrained your solution is to your specific game, since I saw that many fitness functions are very strictly related to some specific attributes of your game, and how is suitable to generalize your solution for more broader platform games.
Yes, that's the main point. If you want to extend, our focus was on the platform game genre, but it can be easily extended to other games, especially if it is a platform game with other features. All you have to do, as you said, is to encode these features, this feature detection in the fitness function, such that it can be evaluated in the genetic algorithm. So this can be really expanded to any kind of platform game as long as you encode your features you want to have in your generated maps in the fitness function. So it's a starting point for platform games, but it can be expanded as long as you insert these new features in the fitness function.
Mhm. Okay. Thank you, Rafael, again.
Mhm.
So let's go to the next paper. Unai, a multi-game toolkit for experimenting deep reinforcement learning algorithms.
So, hi, my name is Marco Antônio. I'm a researcher at the Federal University of Rio Grande do Norte. I'm going to present you Unai, okay? And I'm going to be looking this way because it is where I can see the slide. And let's do this, okay? Let's start. So, I'm going to present Unai, which is a new toolkit to help researchers to carry out experiments with AI agents playing video games, okay? But before going deeper on Unai's concepts, we will first see a quick background about the domain. In the last few years, games have become really popular as environments in which researchers can do AI experiments. Here, we talk about a special class of artificial intelligence technique called deep reinforcement learning, or DRL, that allows the agent to learn how to play a game with less human intervention. So, as games have become popular, they have grown in numbers and diversity. Therefore, several toolkits have emerged to make game environments available to researchers to work with. Here we have two examples, which logos are shown on the left side of the slide, Jim on the top and Ale on the bottom. They are toolkits that provide game environments as test beds for AI agents. Unai is a new game toolkit that allows researchers to do experiments by using several game environments and DRL algorithms. The main innovation is that, aside from having game environments available, it also has DRL algorithms ready to use out of the box. Furthermore, it also organizes all components in a robust and flexible architecture, which is presented here. At first glance, this picture might seem complex, but that's not the case, as we will see. The first layer I'm going to explain is the one at the top of the picture, the environments layer. Environments is the layer in which game environments supported by the toolkit are integrated. Some examples can be highlighted, such as StarCraft 2, Visdoom, and Gem. At the bottom of the picture, we find the libraries layer, where we can access the libraries used to build the agent reasoning. An example is a deep neural network built by using a machine learning library such as TensorFlow or Keras. On the right side, we have the utils layer, which is a set of classes and functions that help us save experiment data and recover them from the disk. Moreover, it can plot graphics in order to aid researchers for tracking the evolution of agents during the training. Finally, we have the core layer, which is the main concept behind Unai. Here is where the training happens. On the top, we have the environment layer that represents the environment and bridges the core layer and the environments supported by Unai. On the bottom, we have the agent that represents the decision-making process of the toolkit. It is composed of modules that control the agent actions that can be performed in the environment, or elements that represent the agent brain, like the model. The trainer is a component that makes the communication between the agent and the environment wrapper, and this is where the training happens. Here we have a list of algorithms and game environments that are already supported by Unai. On the algorithm side, we have tabular Q learning, deep Q learning, double deep Q learning, and policy gradients. The game environments supported are Visdoom, DeepRTS, StarCraft 2, and OpenAI Gym. So, how can we use Unai in order to train agents? First of all, an user should go through two main steps. The first one is to choose the training components. This means that researchers need to select which components will constitute the training, such as choosing an environment, an agent, an action set, and a model. Then, as a second step, researchers will have to tune the parameters for each component. For instance, one can set the number of layers and neurons a neural network model will have. After those two steps, the user can start the training. There are two main ways in which this can be achieved. You can import Unai on a Python script, which is represented in the picture at the bottom left of the slide, and set up your training using Python. Once it is done, you can ask the Python interpreter to run your script and start the training. But if you do not want to code a script in Python, you can set up your training parameters in a JSON or CSV file and use the command line interface to run it. On the upper left side, we have an example of a JSON file. For more details about Unai installation and on how to build a Python script, JSON or CSV file, you may refer to the documentation at the GitHub repository. Now we have a short video showing an agent beating the very easy StarCraft AI. The agent was trained using Unai and is able to achieve 84% of winning rate against its opponent. So this was a quick summary of what Unai is and what can be done with it. Its main purpose is to help researchers by providing a complete solution for carrying out experiments. It already has several built-in features, but there are also a lot of possibilities for improvements, such as improving the architecture even further by adding standards to environments actions and states, or even adding new game environments and learning models. That's why we also would like to invite researchers and developers to contribute with the work by adding new game environments and machine learning algorithms to Unai's architecture. Unai is available on the GitHub address shown on the slide. So I hope you enjoyed and thank you.
Okay, thank you, Marco. Very interesting work. I mean, it seems to be very close to be used by researcher and developer. My question is, if I have a game on a Unity, for instance, how can I? Is it possible to use Unai, for instance, with a Unity ML toolkit or something like that?
You mean if you want to play an agent to play your game?
Yes.
Yeah, if this game has an interface in which you can send commands to it and in which you can retrieve the state of the game on a moment, on a step of the game, it is pretty easy to add it to the structure. Uh, it is written in Python, so the API to access the game should be written in Python. So, or at least have a way to interact with it, like a REST API or something.
Okay. But I mean, is it easy to wrap my attributes and parameters to the Unai, or is more or less? I mean, is there a documentation for that?
Yes, yes. There are some examples. There are some examples that you can use. The already environments, the environments that are already wrapped in Unai, you may use them as a base to create your own environment. Okay.
Okay. All right. Let me check if we have some other question here in this chat. No. Let me see here in the UVA. So just a minute. Okay, no. So thank you very much, Marco. Very nice work. Let's go to the following work, which is dynamic difficulty adjustment in digital games using genetic algorithms.
Hello, everyone. My name is Matheus, and today I'm going to present our paper, Dynamic Difficulty Adjustment in Digital Games Using Genetic Algorithms. This paper was written by me and by my teacher, Paul Adam. So, starting. Many researches are being conducted in this area because the difficulty of a game is linked with its ability to provide fun. So, in order to make a game more fun, it is necessary to balance it for the player that is playing the game. In the theory of flow, Csikszentmihalyi said that for a task to be fun, it cannot be either too hard or too easy for the person that is doing the task. Many studies use its theory as a start point for their research. But how to calculate which is the ideal difficult for a game, and how to do this, and how to maintain the difficult when the player is constantly learning and improving its skills in the game. Many studies are being conducted in order to adjust the difficulty in games in real time by adjusting the game environment for the player's skills. Moreover, these studies have two common characteristics: prediction and intervention. A balanced method must predict where a game has to be adjusted and where the method must and how to intervene in the game when it's necessary to make the game easier or harder for the player. Also, the method must keep the level of difficulty in the game as the player is improving its skills, and the method must be imperceptible for the player. These are some related works used in our paper to study the many ways that this is done. Using these studies as reference for all, we developed an approach using genetic algorithms to achieve the dynamic difficulty adjustment in games. Because we believe that a genetic algorithm has the two main characteristics that is necessary to achieve the balance of a game: prediction and intervention. Genetic algorithms are artificial intelligence algorithms based on the theory of evolution. They are probabilistic algorithms which searches for optimal solutions. After that, for our model, we developed a board game for iPads, the Empire game. That is a multiplayer game where the players must mine resources and build ships. The winner is who reach the biggest score, which can be achieved by building new builds and improvements for their spaceship. Furthermore, our model uses a modified genetic algorithms for the chromosomes genes we are using the probability to mine each resource in the game. So, summarize, for each round, a new chromosome will be used, will be selected from the population, determining the probability to mine resources in that round. When the round ends, the chromosome will be evaluated using the fitness function that is calculated by the difference between the difference of score between the best player and the worst player. After all chromosomes were evaluated, the genetic algorithm takes action by selecting the best configurations and apply mutation, crossover, selection, all of that steps of genetic algorithms. With this, the chromosomes that tends for a more balanced game survives and are used more and more in the game. Finally, we applied the algorithms in our game and tested using these different configurations: population size, mutation rate, and crossover rate. For the metrics, to metrify the quality of our solution, we used the continuous fitness calculated each round of the game and the final fitness calculated in the end of the game. Also, we compared the game with the algorithm and without the algorithm. After our tests, we reach these results. These results calculate the score average and the match progression between 5 games. In conclusion, by analyzing the results showed, we reached 5.8% improvement in continuous fitness and almost 11% in final fitness. Also, the match progression chart shows a continuous improvement in the game, and by modifying the genes, our algorithm is able to be used in any kind of the game. These are the references used for our work. Thank you for the attention. Now I will open for questions.
Okay, thank you, Matheus. Very interesting work, and I mean, it's very relevant also for community. My question is, since you are when we talk about dynamic difficulty adjustment, we should pay attention because we may have very different profiles of gamers. I mean, we can have very gamers that has a lot of experience with these games, and others that doesn't have experience and they're just starting with the game. So in these tests, do you consider it both? I mean, evaluators that had a lot of expertise in the game and people that doesn't have too much engagement with the game yet, since we want to make a dynamic adjustment. I think I mean it must fit for these different profiles of gamers.
Yes, for the initial tests, we used just artificial intelligence agents. For now, we are doing tests with people. But for this test with artificial intelligence agents, you use it three kinds of agents that try it to simulate different strategies in game. There is one agent that is more economist, that's more passive. The another agent that's more aggressive, and another agent that tries to build its economy and at the same time tries to subordinate the others. So we tried to simulate different types of players based on the battle work.
Okay, so but you intend in the future to make a test with different people, because it's difficult to model how a player will behave, I mean, with agents.
Yes,
So,
it is very difficult. I think that maybe
mhm,
it's possible, but
mhm.
we are interface that we are preparing the game to conduct some tests on people.
Okay. Okay, thank you, Matthias. I am looking here in Wova and in YouTube. It seems that we don't have questions. The audience is very shy. Let me. We have a question here from Andrea. I'm sorry. Is there any strategy to verify suspicious player behavior to fine-tuning the game difficulty level, such as when the player is cheating to have difficulties during the gameplay? This is a question made by Andrea Formico.
Mm, as we use it a very controlled group that is the artificial intelligence agents, we didn't do any kind of steps, but this can be a question that we can observe in the test with people now and to see if there's some kind of this. And maybe we have to prepare the game for this. This was a very good question.
Okay. Okay, thank you again, Mateus. Thank you, Andrea, for your question. Let's go now for the last paper of the session, which is an intelligent agent playing generic action games based on deep reinforcement learning with memory restrictions.
Hello, my name is Lucas Antunes de Almeida. I am here today to present the work done in collaboration with the Professor Marcelo Tello, entitled Intelligent Agent Playing Generic Action Games Based on Deep Reinforcement Learning with Memory Restrictions. The topics that we cover in this work presentation are, firstly, a brief summary of our work. The development methodology. We will show the game selected for tests, the obtaining results, a brief conclusion. As the main objective in this work aims at developing an algorithm capable of playing multiple games properly in a similar way to an experienced human player in an environment with limited resource, memory in this case. It is therefore a great interest to avoid the need to specific hard-coded rules and characteristics of a game to the algorithm. The agent test must be able to determine which elements of the environment are being taken at each moment. So, one area that appears strongly related with the development of our agent is one named General Gameplay, or GGP. The neural network agent receives the game image and the score. The image is then submitted to a deep net with 3 layers of convolution responsible for extracting inputs. Then the extracted inputs are resized by a flattening layer. After resizing, the inputs are submitted to 2 fully connected layers, which generate the agent's next move. The agent training phase can be separated into 3 stages. Note: responsible for generating random actions. Exploration: responsible for generating actions that do not exist in the memory. Selection: responsible for selecting the best action. As a constraint, we have imposed memory limitations on the performance test to check results in an environment with restrictions. The memory limitations on the performance test set the maximum size of the memory vector to 8,000 positions. Due to agent selection phase, as actions are carried out, only the most recent and advantageous actions remain in the memory. For the test, 4 games were selected, namely Space Invaders, Breakout, Demo Attack, and Kung Fu Master. Here we can see the game Space Invaders. Here we can see the game breakout. Here we can see the game demo attack. And finally here we can see the game Kung Fu Master. The scores obtained by the agent at each game were compared with those obtained by casual players. Considering that the games have different scales, we decided to compare them using the same scale. This can be seen in this graph, where we can see that one of the games tested, the agent did not reach the score of the human. In two of them, the score was close, and the last game it obtained a higher score. For more detailed analysis, we chose the game in which the agent performed unexpected action. The agent is only limited the enemies that are generated by the game, thus maximizing his score by to increase the difficulty. Observing the evolution of agent's score curve for the game Kung Fu Master, we can notice that it follows a pattern to most executions, which indicates that the agent was able to determine patterns that occur in the game to similar time intervals. Fulfilling the main goal of this work, the agent was able to play multiple games efficiently, being able to determine what actions to take in each game. It's important to notice that we have chosen running the tests in a less robust environment to enable the transposition of these results to other environments such as home computers or smartphones. Our executions of agents were performed at the same parameters. For future work, it's also intended to adapt the agent to perform as part of an actual game. Finally, the authors would like to thank Universidade Federal do Pampa, Cruz pay financial support for part of this work. Thank you.
Okay, thank you, Lucas. It's a very interesting work with where we can see that you achieved very good results.
Thank you.
My question is, which are exactly the memory restrictions that you are dealing with?
We purposely set the memory vector to a limited size, so the agent can run in a small environment, like a home computer or a smartphone.
Mm-hmm. And I mean, and can you tell us a little bit about this, the values of these restrictions? How much?
We use a memory what a 8,000 position, so the agent can store 8,000 frames.
Mm-hmm.
That's because 2 gigabytes of RAM, I think, approximately.
Okay. Yeah, interesting. All right, I think, let me see, just check again if we have questions at WUVA. It seems that we don't have any other questions. So thank you again, Lucas. And with this work, we finish our section. Thank you very much for the audience to be present here. We invite you to visit Discord and make more questions and interact with the authors and other participants of the conference. So thank you again, and please remain on the SBGames, CBGRAPI SVR next activities. Thank you again.